All right, I think we can get started. All right, so good evening. Welcome. My name is Carly D'Amato. I'm the Director of Upper School Admission at SCH. Thank you so much for joining us this evening for our virtual information session regarding our Robotics and Engineering program. In a few minutes, I will introduce our student panelists as well as the Department Chair, Peter Randall. But I always like to start these events by trying to showcase the program a little bit visually. I know most of you have probably been able to see the robotics lab in person and probably have met some of the students and Mr. Randall on a tour. But if you haven't and just want to see the program in action, I always like to share a video. And Peter was kind enough to share with me the season recap from last year. So I'm going to share my screen in a moment so that you can see a little bit about our program in person.
From the rusty time, those years. Don't stay in a daze looking for a sign. Run across fields of ice, but hidden in starlight. Be well aware of roads we've gone by. Put yesterday's aside, meet the future head on. Now trailblazers keep credos in mind.
Okay, so that is, I mean, all of you are smiling and laughing. That looked like what a season. I know you always have fun, and I love those videos that you guys create. So another really great recap. So again, for the families that just joined, welcome, good evening. My name is Carly D'Amato. I'm the Director of Upper School Admission at Springside Chestnut Hill Academy. Thank you for joining us for our information session on our Robotics and Engineering program. In a moment, I'm going to show all of these amazing students so that you can see the members of our Robotics and Engineering team that are going to be sharing about their experiences at SCH and within the programs. I guess maybe I will go around and I'll introduce each of you. You got Peter Randall, the department chair. You've got Leo Cohen, if you want to wave. Nick, Hope, Alec, Cameron, Sean, Devin, Alex, and Ariana. They are all here to share with you a bit more about the robotics program. A couple questions were submitted in advance, so we will get to questions that families asked in advance of the event. But this is also going to be an opportunity for you to submit questions that you have for the students or for Peter throughout the call. So there's a Q&A feature that you'll have access to on your computer, your tablet, your phone. Feel free to submit any questions as they come up, and we'll do our best to get through them. But to start, I want to pass it to Peter so that he can talk a bit about the program.
All righty now. Good evening, everyone, and a special thanks to all our students who have taken some time out from a busy week and joined us this evening. I want to do a real quick overview of the program as we do it in the upper school at SCH Academy, and sort of highlight some of the benefits that I think are of interest to you and your students. Obviously, we do competitive robotics. That's what the film was about. But in many ways, it's about so much more, not the least of which is the kids that made the film. That is a different skill set, different talent. It's absolutely part of what we do, whether it's fundraising or outreach or filmmaking or media or publicity or mechanical programming and driving and competing. It's all part of the upper school robotics experience. We actually do robotics, competitive robotics, starting in first grade. At SCH Academy, we actually have 15 robotics teams from first grade on up. And it was a pretty exciting weekend. Last weekend, we had our final competition for the 2023 robot, the one that you saw in the video. As you might imagine, at the end of a season, it was getting a little long in the tooth. I think we broke just about every system on board the robot at one point over the course of last Saturday. But in what I think is the best example of the sort of resourcefulness and self-reliance of the individuals and team members of this team, they fixed everything and managed to pull a come from behind second place victory out of 30-odd teams, which I think is a pretty commendable result. At the same time, our middle school team was competing down the hall, and our 7th grade team took first place, competing against mostly high school students. And our 8th grade team took 5th or 6th place. So altogether, a pretty exciting weekend. The robotics program is sort of the flashy part of our program. It's what we do that gets the juices running and everybody excited. But we also do an awful lot more. We do an engineering curriculum, both within our CEL program, the Center for Entrepreneurial Leadership, which is a curriculum that everyone takes. We teach a course in microprocessors for 9th graders, and we teach a capstone course for 10th graders, where literally your student would have the opportunity to pursue any topic of interest for a semester. And a number of those projects end up in the engineering and robotics department as design build projects. And then we go into a series of elective courses in engineering within the upper school program. Starting with computer-aided design and manufacturing, we teach kids how to think in 3 dimensions, how to draw in 3 dimensions, and how to fabricate in 3 dimensions. We want them to be able to hold their ideas in their hands, to make manifest that which they're dreaming of. And it is a truly remarkable example of, if you give kids the chance to do something remarkable, they will step up and deliver remarkable things, whether it's a submarine capable of diving to 900 feet or an airplane. We have students that are fabricating a genuine, honest-to-God airplane. In fact, we're working on our 2nd plane. We finished one last spring that got sent back to the factory for wings and electronics, etc. And we just started a new one this fall with a number of these kids. Very exciting projects. We also have a group of students, 3 of whom are on the call tonight. Make sure you ask them questions about high altitude ballooning for NASA. We are flying high altitude balloons up to 100,000 feet for the purpose of doing measurements during the 2 eclipses that are occurring in the US today, this year. So we were down in Texas 3 weeks ago, flying high altitude balloons, and we're headed up to New York State in December and again in April to do that. And what is, I think, even more exciting is that as a result of this participation, it's 81 universities and 4 students from SCH. Pretty heady company to keep. And they're actually going down to the American Astronomical Association annual meeting in New Orleans in January to present the results of our October flight. That's pretty cool. So the net result is we're putting about 15 to 20% of our grads into engineering school. That's extremely high for an independent school. And it's quite literally because we get kids excited about engineering and applied sciences at a very early age in our program. They can see that, you know, this is hard work, but it's rewarding work. It's fun work. It's exciting work. It's hard work. And that's why it is rewarded well and it's more interesting. And they're going to the top programs around the country: Princeton, Penn, Cornell, Columbia, Brown, Johns Hopkins, Carnegie Mellon, RPI, WPI, RIT, Georgia Tech, Virginia Tech, MIT, Caltech, all 4 military academies. And they found their passion for working on challenging material here in our program at SCH. And I think that's what we do better than anybody else. So with that, I'll let them speak for themselves. As we like to say, are there any opposing points of view? You know, feel free to speak your truth as you see it tonight.
Thanks, Peter. So yeah, I think a great way to segue now is I'm going to have you all introduce yourselves. So if you want to go around, we'll start with Leo, since you're at the top of my screen right now and I can see you first. What grade you're in, how long you've been at SCH, what activities you're part of outside of robotics, and then you can pass it to the next person.
I'm Leo. I'm a sophomore. I've been in robotics for last year and this year. I'm part of mechanical team and I'm on the drive team. So I'm taking pretty much all the engineering classes right now. I'm also part of soccer at SCH, but yeah, that's pretty much it.
Nick, you want to go next?
I'm Nick. I'm a junior at SCH. I came here in 7th grade and I've been doing robotics ever since. I'm one of the co-mechanical leads, and I've just my other activities are hockey, chess, and math.
Thank you. Hope?
Hi, I'm Hope. I'm a junior at SCH. I'm also a lifer at SCH. I've been here since kindergarten. This is my 2nd year doing robotics, and I am a co-head of outreach. Outside of robotics, I am a writer for our campus newspaper. I also am a part of the Girls in STEM Club and the GSA.
Thank you. Alec?
Hi, I'm Alec. I've been at SCH since kindergarten. I'm the lead of the media team, and I've been doing robotics for this year and also last year. And outside of robotics, I'm part of the newspaper club and also honor council.
Thank you, Alec. Devin?
Hey everyone, my name is Devin. I'm one of the captains of 1218. I'm also the other co-lead to the outreach sub-team. At SCH, I guess I've been here since freshman year, 9th grade. I've been a part of robotics all 4 years. I've also been a part of the Nationwide Eclipse Ballooning Project, which we can talk about more, as well as the Aerospace Robotics Competition, the drone team that we started last year. I'm also part of DEI Council, Honor Council, the co-lead to Library Club. And I'm sure there's more things that you can get involved in at SCH. This is some of the stuff I'm involved in.
And an insect nerd.
And an insect nerd. Ask me about that anytime.
I heard all about that from the trip to Texas. So, Sean?
Hi, I'm Sean. I'm a senior here. I've been at SCH since second grade, and I got my start with robotics in middle school. I am a co-lead for our electrical and software sub-team, along with Cameron, who's also here. And outside of robotics, I'm also part of our squash team, formerly a member of our crew team, and part of our math club and honor council.
Thank you. Cameron?
Hello, my name is Cameron. So, I mean, of course, along with Sean, I am the co-head of our electrical, pneumatic, and programming sub-team. Also, I'm a member and driver of our ARC drone competition team. Along with Devin, I'm part of the Nationwide Eclipse Balloon Project. And outside of robotics, I'm a co-captain in squash and a member in a multitude of clubs and activities.
Thank you. And Alex, and then Ariana.
Hello, I'm Alex. I'm a sophomore in high school. I came to SCH in pre-K and have been there ever since. I started my robotics career pretty much as early as I can remember, so around first grade or so. And outside of robotics, I've been doing various activities, some of them being squash and hill tones, the school's a cappella group.
Hi, I'm Ariana. I'm a freshman this year. I've been here since kindergarten and been in robotics since first grade. I'm one of the mentors for like the middle school robotics, and outside of robotics, I do crew, and airplane building.
Everyone. And again, families, you can submit questions at any point. Peter, I don't know if you want me to ask a question or if you want to start with a question for everyone.
Well, I would like to ask all of these guys to, in as few words as possible, what makes robotics special to you? Leo, kick off.
What makes robotics special to me is really just like all the sub teams coming together, especially like right at the end of like right before competitions. Everybody kind of just gets together. We like all contribute to what's going into the competition, and yeah, that's what makes it special for me.
What makes it special
Nick?
for me is the community. Every single person on the team, the students and the teachers, are just so welcoming that even if you're just starting out and have no clue what you're doing, it is so easy to get involved and to find a place. And no one, even if you have an idea that may seem out of the box, no one just dismisses it and goes, that's a dumb idea. They help you with your idea.
Anyone else?
I would also say the community. I feel as if it's a very tight-knit group of people, and it's kind of a group of people that I feel as if I wouldn't know if I hadn't joined robotics. So it's very fun.
Anybody else have a specific contribution?
Yeah, I'd say the one word I can describe robotics is versatility. I mean, you can be, as we've all talked about, you can be part of outreach, you can be part of media, mechanical, coding, electrical. There's so much to do in the program. It's really wild. And so it's really for everyone, business and branding. And so like when Mr. Randall says like, you know, this is a space for everyone, it like really is. Everybody can find a passion here. It's robots, but it's also much more than robots.
Thank you.
Okay, throw it back to you, Carly, for questions.
Okay, so I think there are a lot of families on here that are looking for ninth grade, and we've got a great variety of students here that have come in lower school, middle school, upper school. I think it'd be really helpful for us to be able to chime in a little bit about what the experience for a ninth grader looks like coming into SCH. And I'll break it into two questions. A, what does CEL and the microprocessing class look like for students that take that as ninth graders? And then B, how do you get involved as a ninth grader? And if you haven't had these experiences before, do you feel like you're at a detriment? And you guys can just unmute yourself and chat.
I would say being a freshman, well, if you want to get involved in robotics, it's pretty easy. There's an activities fair and you just sign up and then like go to meetings, and it's like really inclusive. So it's really fun and easy. You don't have to know how to do anything, like literally anything. They'll teach you everything you need to know. And also in terms of like the microprocessor and coding, CEL, I haven't taken it yet, but I'm taking it next course and I'm really excited to.
I took microprocessors and coding my freshman year, and I absolutely loved it. I knew absolutely nothing about engineering before I took it, and it's actually one of the reasons why I joined the team, because I really enjoyed that class so much. Like kind of going off what Ariana said, you absolutely do not need to know anything about engineering to join robotics. I knew basically nothing, and now I'm a co-head of outreach with Devin, which is something I never thought I would do, because I was kind of just like, oh, I don't know STEM, I'm not going to join it. And then I did, and I found out, wow, I didn't really need to like know anything beforehand.
Yeah, going off that, when I came in once we got our game in January, I kind of spent like 3 or 4 weeks just working on a claw. I no clue what to do or anything like that, but I worked with the mentors and learned from the people around me and how to make it. And I went through like 19 iterations of the claw, but finally I like landed on something that worked. And yeah, that was beautiful because it was just working with people that knew more than me, so all learning from each other. And yeah.
Yeah, I think a key element of this is that a claw designed by a freshman is on our competition robot. That's pretty cool.
Anyone else want to chime in on any of that? Devin, maybe as another student that came in new.
Yeah, I was just thinking about that. I came in, 9th grade, with an idea of what I wanted to do. I really like STEM. I really like engineering. And I took the microprocessors CEL course in 9th grade, going in with virtually no knowledge. I knew what like the word coding was. I knew the term JavaScript, and that was kind of it. I did not feel at a disadvantage whatsoever. Mr. Randall and the other mentors and teachers who are part of CEL and just part of the SCH community in general are really, really good at making sure that, a student who's been here since preschool knows as much about a subject as a student who has just come in 9th grade. I found that, my lack of knowledge in a subject didn't really impact my capacity for learning in any way in any class.
And he's one of our co-captains this year, so clearly he has succeeded in some fashion.
I think another question that I'd be curious to hear you guys talk a little bit more about is maybe what you're actually working on when you're in the microprocessing and coding class. And then from there, maybe a show of hands to start. How many of you through the CEL capstone project worked in the innovation lab for your projects? So maybe talk a little bit about what the microprocessing and coding class looks like for 9th graders. And then for the students that did do their capstone in Innovation Lab, I'd love to hear maybe a little bit more from you. And then if anybody else wants to chime in about their projects, I also think it's cool to hear what other students were doing through there.
From the CL9 microprocessors, I learned a lot of just basic coding and how to actually like write some code and read code, which I've never really done before, and also like how to integrate sensors into the code, which kind of helped me with my CL10 capstone. For that, I made a remote control sailboat, which I needed to use some electronics for to be able to steer it. But I also had a lot of kind of mechanical more stuff of how to actually make a hollow boat. So I had to 3D print a mold, and then I used that mold to kind of wrap hot plastic around to create a hollow boat for it. And it was a very cool process that I was guided through by the mentors.
Leah, would you like to chat?
Yeah, so I took microprocessing and coding last year in the first semester. what it looked like for me is it was like a series of probably 10 to 15 challenges that you work through along with the teacher's help. And you're doing like a hands-on thing in the first half of the challenge where you're working with an Arduino board and a circuit board to plug in wires and plug in lights and wire everything up to get it working. And then the second half is working through code that is like it's helped on with the mentors, but there's some stuff that's like blank and then you have to figure it out, and there's some stuff where you can make your own iterations to it. So I really like that part. And then once you finish those coding challenge, it's kind of like a work at your own pace class. You can start your own like passion project that has something to do with an Arduino board and coding. So yeah, and then for capstone, I'm currently in the invention studio, and me and another member who's in robotics is working to turn harmful chemicals from smokestacks into a pretty much laughing gas that we can sell to pharmaceutical companies for a profit.
That's awesome.
Trash to treasure. It's always a good mix.
Very cool, Leo. Very cool, Nick. Devin?
Yeah, so unfortunately my CEL circuitry class was kind of cut short because of COVID. So it was kind of a different year. However, we still did all the challenges Leo was talking about. We just didn't have as much of a end project, but it still really helped me for capstone since I built a water filtration system that runs off solar energy, and it's like an entirely sustainable system. And the circuitry, like on a basic level, the wiring and the circuitry that you learn, or at least I learned in 9th grade via the Arduino class, did actually come in handy when it came to wiring up a solar panel and a battery and a water filtration system and a water pump. And like actually, surprisingly, circuitry is kind of, somewhat universal. And it actually helped to have taken that class. So it was really beneficial for me.
I'd like to point out that not only did his filtration system work, but it fits inside a suitcase. Very cool.
Awesome. Anyone else want to plug their capstone projects or anything regarding the CEL classes that they thought was helpful with this program?
Sure. So my CL project, me and a friend modeled a eco-friendly tiny house for a homeless housing company in Center City, Philadelphia. And I didn't really use what I learned in microprocessors, but I learned I used what I learned in CAD/CAM engineering last year, which was how to 3D model an actual real life thing and have it be to scale. So basically what I did was we took the blueprints from that house and then I CAD/CAM'd it to scale and made a full 3D model, interior and exterior, using what the actual materials would look like in real life. And then my friend took that model and she made a to scale tiny version in real life outside, like out of wood. And then we gave it to them so that way they could use it to be able to like build their actual houses.
Very cool.
Absolutely. Anyone else? Or you can move on to the next question. Cameron? Yeah.
Yeah. So I just want to talk a little bit more about the microprocessing class a little bit and a little bit about my CEL. During the microprocessing, when I was a freshman, this was during COVID. And so all this stuff was mainly online. We had to go into school one day, pick up the microprocessing kit and work on it at home. And I think one of the key factors that I grabbed, and I feel like a lot of other students grabbed, was sort of like the spark that started engineering. This is like the tip of the iceberg when it comes to the engineering curriculum, as it provides sort of like the basic needs and skills for engineering, whether that be circuitry, coding, etc. And I feel like when I went through there and sort of gathered this passion for robotics and engineering, I sort of helped continue it. I was like, all right, well, now I'm done with this. Now, oh, look at this new engineering class that I can now take called CAD/CAM. Oh, look at this, I can do engineering. I'm building a whiteboard drawing robot. I'm now flying a drone. Now I'm launching a weather balloon 100,000 feet in the air. it's sort of like a really good branching point for a lot of students to help make sure that they can get the understandings of how engineering works on a basic level, but also helps them realize that, like, man, I really like doing this. And one of the main things that I got, despite not being in the innovation studio during my CEL, I was still able to utilize some of the coding experience to develop a WordPress website for my capstone project, which is to help seniors navigate the web and interact with modern technology safely and efficiently. And this has sort of exponentially grown to the point in which now we're incorporating artificial intelligence into our product to help seniors in the most efficient way.
So cool. Thank you, Cameron. So I have more questions that I could be asking, that some that were still submitted, some are coming in as well. So feel free to use the chat feature to submit questions. Peter, for you, a question that just came in: how many faculty members and mentors are involved in the robotics and engineering program and curriculum?
Well, I can say that 20 years ago, it was me and one other crazy fella who decided to try and do this thing. And now it's 6 of us on staff at SCH. So we have 2 in the upper school, 2 in the middle school, and 2 in the lower school that are on staff at SCH that are involved in our after-school robotics program. In addition to that, if you were listening carefully, one of our students mentioned that they were mentoring middle school students. One of the requirements of our upper school team is that you participate in after-school mentoring for the younger students. We do this for a couple of reasons. One, the best way to learn a subject is to teach it to somebody else. That's how I learned all my engineering. And the second is that it allows us to have a much more robust program for the younger students, because in many cases, it really requires one-on-one and one-on-two levels of support to get started, especially in middle school and lower school. And by providing upper school mentors, they see where they're going, if you will, and the kind of folks that are involved in it. And it's worked out extremely well for both the upper school students as well as the middle and lower school students. So we're very excited about that.
In addition, besides the SCH faculty that we do also have quite a few outside members and also alumni who come back to support 1218, our robotics program.
Yep. So we have alums coming back. We have retired faculty coming back, and we have parents and relatives of current and former team members that are helping to support us.
Thank you. So a question that was submitted was, how do students participate? What's the time commitment and the allotted time that students have? As everyone has shared, you're all involved in a lot of things outside of robotics, and there's school as well that you have as part of your day. So I'm curious, what is the time commitment? What time do you have during the day after school that you're able to contribute to the robotics program?
I would say
Let me get you. Let me sort of put some parameters around that, and then let the kids answer specifics. Robotics meets a lot. I mean, we meet every afternoon. We meet during activity block. When we're in build season, we meet 5 days a week, 6 days a week. But we do not expect any one student to be there at every meeting, because they are all doing other things, and those things have fixed schedules. You can't row a boat without all 8 rowers in the boat. You can't rehearse a play without all the actors on the stage. You can't sing in an a cappella competition with no bass section. We understand that. With the exception of competitions, we expect kids to commit to robotics that which they can afford to commit. And beyond that, we want them doing other things. And so now, students, how does that look to you on a day in, day out basis?
I would say like the biggest thing is that you don't have to go to like there's a lot of time, which a lot of times is overwhelming to people. They're like, oh, I can't do that. It's too much of a time commitment. But really, that's not because you're not supposed to be there all the time. It's only there so that you can go to robotics. And like I do crew and stuff, so that takes like a lot of time because it's a pretty big commitment. But I'm able to do both and like be committed to both, and I think that's really great. As well as like players and other things that a lot of kids do. I know there's a lot of robotics people in players or in band or in orchestra. And it's and like all of them can do everything and are able to manage stuff really well.
Yeah, even like despite having extracurricular activities like sports and stuff outside of school, robotics meetings, especially during the season, tend to go a bit later. And that will and then once you're in season, despite having practices that'll go to like 5 or 6 on like Tuesdays and Thursdays, the main days where we're having meetings, those will go extra late, so you can just like join your sub team, get some extra work done, even like despite having all these extra obligations and other activities that you're doing. So there's not like a constant requirement to always be present.
Yeah. Also, I mean, during the competition, we have 2 days a week that go to 8 o'clock. But besides that, there's time to meet pretty much throughout the entire year. We meet after the season is over. We meet during the summer. We meet during the off season. We're pretty much always doing something in that lab, and there's always the opportunity to get involved. So yeah.
Fantastic. And you had all mentioned the sub teams and committees that you're part of. How do you figure out what you're a part of?
So you go.
So for me personally, I came into robotics interested in like coding and programming. But I said before, I'm one of the sub team leads of media, so that's not really connected. So I kind of realized that personally, I'm not interested in coding. And so I tried other things and eventually landed on the fact that I enjoyed making videos, like the video you saw at the beginning. I didn't make that personally, but it was made from someone on our team. So I do stuff similar to that, but I realized that that's something that I enjoy doing, and I've had a ton of fun on the team ever since I started doing media stuff. And so I think it's more so you kind of just have to, you should try as many things as you can, because you'll eventually find your place. And even if you don't end up finding your place, every other sub team, even if you're not super interested, is still fun. I still had fun on doing programming. Well, I still wasn't interested. It was still end up being like a fun experience because of the people.
We also host different sub team leads host kind of an info session every week. So this week is, I think, CAD CAM, which is the computer aided design sub team, which actually in charge of making the 3D model. But we host one of these events every week to kind of teach the new members what the different sub teams are. That way you can see, oh, I never even knew what CAD was before this, but now this seems really interesting and something I want to do.
Also, if you're
sorry,
you can go. Also, if there's like multiple sub teams you want to do, you can be a part of more than one sub team. And if like Alec was saying, you don't like the sub team, you started on a sub team and you didn't really like it, you can always change. Because you can always go to like another sub team and you'll still be able to learn new stuff, because there's always freshmen each year who are learning as well. And yeah, so you can be a part of more than one sub team and be committed to more than one sub team.
And my advice to, I guess, anyone joining the team would be just to, try as much as possible. I kind of joined the team initially thinking I would be doing stuff focused in like mechanical, because I had taken the CAD and mechanical engineering class. But one day I, did a little work with an upperclassman who was working on some software, and I just got sucked in. So, yeah.
Yeah, you got to watch out for the whirlpool. It will suck you in.
Awesome. A question was just submitted more about the engineering curriculum, and if you could share what the classes are that the students have access to, and then if people can talk about the projects that you've worked on within those classes, especially like the submarine and things like that.
Cool. So yeah, as everyone has mentioned, our 9th grade classes are microprocessor class. You know, at the surface, it's about microprocessors, but really it's more about learning how to approach problems you've never seen before. We know that most ninth graders have never touched a microprocessor, and that's quite deliberate. We want to ask them questions we know they don't know the answer to, and then teach them how to resolve that dissonance and figure out how to approach those problems. And it happens to be a lot of fun, but in the end, that's what we're driving for. Capstone program also in CEL is a 10th grade class. Also in 10th grade, you can take our introductory classes in CAD/CAM and introduction to mechanical engineering. That's each are 1 semester classes. Then there's an honors engineering class, which you can take junior and or senior year. And we have a number of people here who are doing it for the second time with special projects like our NASA project. In addition to that, we offer an advanced real-time programming class. These are folks that are particularly interested in the electronics and software involved with the Internet of Things, or robotics programming, or avionics systems programming. And so we have a number of kids that are doing that. We offer a class in aero engineering where you can literally learn how to fly. Our students at the end of the class are able to sit for the FAA private pilot's license. We do not teach the physical aspects of how to fly. You have to go to a certified flight instructor for that, but we can teach you the book learning necessary to get your license. And we have graduates of that class that are flying jets for the Air Force, that are designing rockets for SpaceX, that found their aero experience in at SCH. And I think that's about it. If somebody comes in with a really cool idea, we'll figure out how to make a class about that idea.
Thank you, Peter. And do any of you want to talk about the projects that you've been working on over the last year, 2 years or so?
I mean, one thing very recently, I've done a lot via the engineering program. I'm really lucky to have been a part of it and learned so much. Probably my favorite project that I've been on is the one that I'm currently still on, which is the Nationwide Eclipse Ballooning Project, NEBP. As Mr. Randall said, we're one of the only high schools in the nation that is a part of this program. It's mostly universities. We're partnered with Drexel University right now. And basically, on October 14th and in April, we have and are going out to see the solar eclipses that are coming over the US. You should absolutely go to see the one on April 8th if you can. And we are launching a high altitude weather balloon with a bunch of atmospheric sensors on it to collect all sorts of interesting data on, how does this celestial phenomena impact life on Earth, impacts information and, the molecules in our atmosphere. It's a super interesting project. And this was not a class until this year. It was we applied last year and we got into this program, and now we're a NASA funded team of 4 high schoolers and some college kids. And so it's been amazing.
What is your particular study in this particular program?
Yeah, so in line with the Eclipse ballooning program that we're part of, I am collecting audio data on insects and birds during the eclipse. And so while we were in Texas in October, I had this small device that can collect information, frequencies from, the sound of a car honking all the way to the ultrasonic frequencies that moths make. And with that information, I'm currently putting together a conference proceeding for when we're in New Orleans at AAS, and I will be presenting there with my findings. I'm first author on this research study that I'm currently conducting. I'm working with the Academy of Natural Science on it. It's so fun. Once again, if I didn't, come to SCH, it would not have been an opportunity that basically fell into my lap.
Very cool. Anybody else got a project that they're particularly proud of?
So it's still in the early phases, so it's not necessarily something that I'm proud of quite yet, but something that's a lot of fun is right now I'm working on a 1-pound battle bot. So I don't know how many of you guys have seen the TV show Battle Bots, but pretty much it's competition based off having 2 robots battle each other. There's the small weight class is under a pound. So you have to somehow make a robot that is under a pound and can still cause damage to other robots. So while I'm doing this, I have successfully made a drive and I'm figuring out a way to be able to throw the other robots up into the air and have them fall down and have them take damage by doing that. It is a very, very fun project using a bunch of different ways of like mechanical storage of energy, how to get some mechanical advantage stuff. It's a really, really fun project.
Sean or Cameron, you want to talk about ARC last spring?
Yeah, sure. So one of the projects that myself and a few other students worked on for about like a semester last year, and we're planning on continuing it this year, was building a drone for a competition called the Aerospace Robotics Competition. And so we built and programmed a drone to, I guess basically the competition was to pick up some tennis balls and drop them in the hoop, which sounds simple, but is far from it, as we learned the hard way. And we spent 4 or 5 months working on that, and we eventually were able to win the competition we went to. And so we had a lot of fun with that. And I also wanted to mention, like, in the honors engineering classes, we also work on some just smaller fun projects. Like last year I made a lock that will open if you knock the correct pattern. And I know Cameron and Devin have also done some stuff like that as well.
Awesome. Fantastic. Another question was just submitted. How does the middle school robotics team relate and connect to the high school team?
Good question. So our middle school teams actually break into 2 subsections. There's the 5th and 6th grade teams, which are Lego based and compete exclusively within the middle school. Our 7th and 8th grade teams actually compete in what's called First Tech Challenge, which is a fabricated robot, aluminum, plastic, steel, 18 by 18 by 18. So it's a smaller format, but it's a designed and fabricated robot that the students have to design for a specific challenge. And that competition is primarily a high school competition. We compete with 7th and 8th graders. And our 7th grade team beat all the high school kids last weekend, which I think is ridiculously cool. And they are so pumped to work hard this week, which is what we're looking for. With that as sort of the context of what our middle school program is, we have 2 full-time faculty members that are mentors for those 2 teams. And then we have a whole bunch of these guys acting as team mentors. So who's working with FLL? Anybody in here working with FLL? How about FTC? Okay, so just a random assortment of kids here that are donating time after school to help the middle school students. Would you describe it as boring or fun?
I'd say it's kind of a mix of each. I mean, you have you'll have some times where the children are, they're getting to learn like their boundaries and like what they need to do. And because FLL and FTC are kind of like lead ups and build ups to like the big competitions at FRC, It's kind of just like a way to introduce the kids into getting into the spirit of robotics and kind of understanding more about the about like the competitions and about the games. And so it's a really good way to like understand and build up like the people and the kids' understandings of the sport.
Yeah, another aspect about this, which was not mentioned, is we actually host two competitions a year. One for the 5th and 6th grade teams, the FLL Lego teams, and then we also host a regional qualifying tournament for the FRC. It is actually the largest event that school hosts, and has been for years. It's 3 days, 1,500 kids. It's loud, it's exciting, it's fun. Absolutely, March, I think it's 15, 16, and 17 of this year, next spring. Come and visit us. It's going to be a wild time at SCH.
I feel like we invited families of enrolled students to that
Last year. Yep.
Last year. So families on the call, if your child ends up coming to SCH, you will be invited to come to that in
Super fun.
Yeah. We have another question. We're getting close to the end. Appreciate all the questions that have been submitted. This question comes from one of our parents. I lead the technology group in a large architectural and engineering firm, and we design projects using building information modeling, where every 3D building component modeled is data rich and helps us analyze and optimize our designs. For example, we use our BIMs to determine the heat loss performance of the exterior enclosure design and so forth. Do you do something similar with your 3D models? Are they operable digital twins in any way? And how much travel is involved in this program?
I'll answer a couple of those. For starters, yes, our 3D model exactly replicates our physical robot. In fact, we don't begin cutting material until we have a 3D model, primarily because the clearances and tolerances are so tight. For a 6 foot tall robot, you've got clearances of 1/8 of an inch in various dimensions that have to be met. And we have to make sure that our ideas will fit within that envelope. And so, yeah, we model everything. And then we utilize the CNC computer numerically controlled tool set that we have, milling machines, router tables, laser cutters, 3D printers, to fabricate a lot of the elements on the robot from those 3D models. Specifically as regards architecture, we actually have a licensed architect on staff in our CEL department who teaches architecture as one of the options within the CEL program, and does a lot more with the architecturally oriented software, Rhino, AutoCAD, than I do. We're focused more on the engineering and fabrication side. She's more interested in the design and building side. I will tell you that my son went through a 4-year curriculum at Virginia Tech in construction management and is now building a school up in Bensalem. And he absolutely is using a BIM system that is very similar to the ones that we teach for engineering. So yeah, it's certainly part of the trajectory for these guys.
And how about travel, Peter? And then maybe go ahead.
Yeah, the answer to travel is we travel a lot. The folks on NEBP have already been to Texas once. They're going to New Orleans. They're going to upstate New York twice. They're it is a fair amount of time where we're going to drag their butts out of school for exciting stuff. I don't think any of them regret it. And so the robotics team itself, the competitions, as I mentioned, are 3 days long. We'll do 2 local competitions here in Philadelphia area. We'll do one up in upstate Jersey, which will be an overnight. We'll do a competition down in Houston if we qualify. We have qualified 19 out of 20 years, so I'm optimistic. But we have to qualify in order to go to the World Championship again. That's a 5-day trip. It's a long way there and back again. But one of the things, we're the only activity I know that has its own academic dean. Dr. Sperling is a co-head of the program, and she is on top of every student's academics to make sure that they're A, qualified to travel, and B, stay up to date as they're away from school. So there's a lot of travel involved. There's some expense associated with that travel, but we do our best to offset that through fundraising. Thumbs up if travel's a lot of fun. Yeah, Mr. Randall's not really good with airports and kids, so let's just say it's a pretty tight ship when we get to an airport.
Awesome. We're getting close. I mean, it's 8 o'clock. Any final thoughts from any of our students that you'd like to share about SCH, the program, anything that you think would be helpful for our families to know and understand as they are considering us and other amazing opportunities in the area?
Those of you that joined us in 9th grade, why did you pick SCH?
Leo, do you want to go first?
You can go, Devin.
Sure. So I initially joined because I was thinking to myself, I really want to do engineering. I want to, be an engineer when I grow up. I really like STEM. And through this program, I learned how much I really like the natural sciences, which is kind of crazy because I started out, I toured the lab, I heard Mr. Randall's spiel, I saw the airplane hanging in the, in the space, and I was immediately hooked. And so I saw all of that, and that's what immediately grabbed me in 9th grade. And I've stayed because I've done so much and I've had so many opportunities I didn't think I would have ever had as a high schooler. And so it's been phenomenal. It's been such an inclusive community I've been a part of. It really is as simple as walking up to someone in the space and saying, hey, what are you working on in robotics? Can I help? Can I join what you're doing? And 99% of the time, the student is totally willing to help you. And that's the experience I've had and would not have traded it for anything. I have friends at a bunch of different schools, and in comparison to what I'm doing in STEM and what every single person is doing in this call, it's really not comparable.
Leo?
Yeah, so I came in 9th grade. I went to public school in the city for 9 years, and 2 years ago, I don't know if some of you guys know about this, but the public school system kind of got messed up through a lottery-based system, so it wasn't a guarantee where you were going to go if you applied. So we looked into the independent schools, and I applied to around 9 independent schools in the general Philadelphia area. And through that process, I was shadowing and touring a bunch of these schools, and I came to SCH shadowing one of the current robotics members. And I knew immediately this was a different experience from any of the other schools that I'm shadowed. Just the lab that we had that was available was unlike anything. The amount of machinery was exactly what I was interested in. I was really interested in 3D printing at the time. I had my own 3D printer, and we had a whole classroom based on 3D printing. It was just, and that was my first time that I heard about FRC too. So that immediately hooked me because it was just something I've always been looking for since I was a kid. So, I mean, yeah, it was pretty much an instant click for me as soon as I shadowed.
Cool.
Anything else anybody else wants to share or add as final thoughts?
I mean, like I said before, I've been at the school for 9 or 10 years at this point, and I think, just to be concise, it's the robotics team has been one of the most fun experiences I've had the entire time I've been at the school. And so if you end up coming here, it's like I cannot urge you more to join it because, like I said, throughout all my time here, it's like just one of the most unique and fun things I've done.
Yeah, just continuing off of that, again, as mentioned prior, the community here and the friends you'll make along the way when you go through your like high school career, they're kind of like a second or like a third family to you. And honestly, it's a great community that I think you'd probably want to be a part of.
Thank you, everyone. Thank you so much. I love doing these events. It's always so cool to hear what you guys are working on. I feel like I've got this smile I gotta work on kind of relaxing right now. You're all really impressive. It's always inspiring to hear your stories and to hear that you're able to pursue projects and things that you're passionate about, and that the things you started off loving can evolve and change into these really unique and amazing opportunities. And so it's just great to have this time to hear it from you yourselves and for you to be able to share it with our incredible families that for many of you that are attending, you've been in the lab, you've probably met some of the students that are on this call, and you've probably definitely met Mr. Randall. If you haven't, we are always happy to have you on campus, to show you the lab, to have you come and spend a day with us. So for many of you, I know you're applicants already and you're in the process. If you're not, there's still time to apply, and we can always try to find a way to get you into the lab either during the full day visit or after school sometime. So to our families, thank you again for being here. For our students, you're incredible. Thank you so much for being here at 7 o'clock on a school night, Mr. Randall. We look forward to continuing to get to know your children through the application process at SCH. If you have any questions about the robotics program, you want to talk to any of these students, you have specific questions for them or for Mr. Randall, please know you can email me and I'm happy to try and get you connected so that you can have your questions addressed. But for now, I'll say thank you and good night.